to you by thesis123.com. I learn and teach online.
Okay, so here's the next question, number 2. This is for 2016 electrical paper set 2. So the circuit shown below is an example of, we have our 4 options: low pass filter, band pass filter, high pass filter and notch filter. Okay, so let's look at the circuit given to us. Now this is an operational amplifier circuit, or also known in short as an op-amp. So we have an op-amp here, and we notice that there is a feedback path, and the feedback path has a capacitor in it. So that should give you a clue, because an ideal integrator has a feedback path with a capacitor in it. So I'll write that down. Ideal integrator is an inverting amplifier that has a capacitor in its feedback path. Alright, so it is these clues that enable you to find out which type of filter it would be. So an ideal integrator is the one that has a capacitor in its feedback path. So the next step is to see what the ratio of the output to the input is. Now if the output to the input indicates that it is indeed an integrator, then that will tell you that it would be a low pass filter. So let's just check that out now. Let's look at the ratio of V out to V in. Now V out to V in, let's note that down as Z2 by Z1. Now because there is a feedback path, I'm including that as a negative, so that's minus Z2 by Z1. So we're taking it in terms of impedance here, the ratio. So minus Z2, in terms of what we have here, we have a capacitor. So we write that as 1 divided by SC by Z1 is R1. So let's just note that as R. Now if we simplify this, we can write that as minus 1 by SCR. Now to put this in better perspective, we can say that the output is minus 1 by SCR times V in. Okay, so if we were to convert the S in terms of time domain, then we can simply write this as V output is equal to minus 1 by RC V in. Now this is in our time domain. Now if we integrate both sides, we get V out, this is dot. Now if we have to convert it into S domain, this is V out dot, so that's differentiation. So this is a derivative. This equation is a derivative, please keep in mind. So this is in time domain. So this is the derivative, and in order to find out what V out is, we integrate on both sides. So when we integrate on both sides, we get V out is equal to minus 1 by RC integral V in. So this is the general notation, a very quick view of how we see the output in terms of input, which is an integration of it. So because of this equation, we see that the circuit given is indeed an ideal integrator. Now if it is an ideal integrator and has a capacitor in its feedback path, it represents a low pass filter. So that is our final answer. I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.